All right, so now once we have that fact, we can look at other functions that involve natural logarithms and work out some of the derivatives. So there's a few different examples here to work with. We have, first of all, y equals ln of x squared, which means that, even though you don't write the brackets there, if we want to find the derivative of this, well, the derivative of ln of something, right? Because we're going to have to use the chain rule here now, of course, right? Because we have ln of another function there. So the derivative of ln of something there is 1 over that something. But then we need to do the multiply by the derivative of that inside function. The inside function is x squared. So the derivative of that is 2x. So if you simplify that, I have to put it over here, y prime equals 2 over x. That's the simplified version of that. Second thing over here, we have ln of 3 over x. The derivative of that, right, derivative of ln of something is 1 over that something. 1 over 3 over x multiplied by the derivative of the inside of that function. The derivative of 3 over x is negative 3 over x squared. You can go through and use the power rule, change this to 3x to the negative 1. Eventually you'll get that. So I'm going to put this over here, negative 3 over x squared. To simplify this, we'll put it down beside here, and not quite enough room. We have x over 3 times negative 3 over x squared. What that is going to be is actually negative 1 over x. That's the derivative of ln of 3 over x. Now, before we move on to another one here, there is another way. If you know some logarithm laws, sometimes you can simplify things, because that would be one you could simplify. I just need some room here, but not a whole lot of room. I'm going to put it up above here. That you could actually write as, because it's the ln of a quotient, you could write the function as ln of 3 minus ln of x. That's really simple to find the derivative of, because this is just a constant. Ln of 3 is a value, so its derivative is 0. And that's just the basic natural logarithm function. So its derivative is 1 over x. And so y prime being 0 minus 1 over x, or just minus 1 over x, same thing as we had down here. So if you know your logarithm laws, sometimes you can make things a lot simpler by using them first, rather than doing all this algebra over here. All right, let's look at this one over here. We're going to find the derivative of that. Y prime equals 1 over 3x plus 3 times the derivative of that inside function. Derivative of the inside function is 3. If you simplify all of that, you get y prime is 1 over x plus 1. Right? Divide everything by 3, you get that. Not much room over here. I'll fit it in though. Same idea here. Y prime is going to be 1 over x squared plus 5 times derivative of the inside function, which is 2x. So you got 2x over x squared plus 5. That's that derivative. Didn't leave myself a lot of room here, did I, for each of these? Y prime ln of sine, so it's 1 over that inside function times derivative of the inside function. We can write it as, right over here, cos over sine, or if you actually wanted to, you could write it as cotangent of x for that function. We have ln x squared. That's different than what we had up here, which was, this was ln of x squared, where the x squared was the inside function. Here, the natural logarithm is the inside function. So our y prime here is going to be, we first have to deal with the something squared. So we got 2 times that something, right? Something squared, so we got 2, not that I need brackets, 2 ln x times the derivative of the inside function, which is 1 over x. So simplest way to write it, 2 ln x over x. And then the last couple here, that one's a product. We have to recognize here that this is a product, x times ln x. So we're going to have to use the product rule. We have x prime times ln x plus x times ln x prime. or in other words, 1 times ln x plus x times 1 over x. What do we have here? Ln x plus 1. That's that derivative. All right? Fairly simple result in the end. Last one over here. This is not a product, it's ln of ln x. So first we need to look at the outside function, which is ln of something. So we're going to have, right, this ln of that. That yellow is the inside function. So we're going to have, first part is 1 over that, ln x. But then we've got to include the derivative of the inside function, which is ln x. The derivative of that inside function is 1 over x. So we actually have y prime is 1 over x ln x. All right? So there you have the derivative of the natural logarithm function, and then some other functions, compositions, products, etc., that involve that natural logarithm function.